Today we're going to be looking at the periodic table and all its layers of organisation. It really is a thing of beauty and something that we should all understand as students of chemistry. Dmitry Mendeleev, a Russian scientist, is widely considered to be the father of the periodic table. Благодаря, Dmitry. What Dmitry did was he took all of the elements that had been discovered and he realised that they must go together in some kind of order. This was a very, very tricky puzzle when you didn't know what it looked like. Of course, it didn't look like it does now originally, but it has evolved over the years. And we now start with atomic number 1, hydrogen at the top left with 1 proton. And the elements go up in order right up to number 118, which has since been named organesson with 118 protons. The next level of organisation in the periodic table is the groups. The groups are the vertical columns in the periodic table. There are 18 groups as numbered here. And the first thing they have in common is that members of each group have the same kind of chemical reactivity. For example, in group 18, they are all unreactive, the noble gases. The next thing they have in common is that if they're in the same group, they have the same number of valence electrons. E.g., elements in group 2 have 2 valence electrons. The next layer of organisation is periods. Periods are the horizontal rows in the table. There are currently 7 periods. Elements in each period share the same number of electron shells. For example, those in period 4 have 4 electron shells. Having a look at this line down the middle in black, it looks like a staircase, divides the periodic table into metals and non-metals. Those elements on the left are the metals. Most of the elements on the periodic table are metallic: silver, shiny, conductive. Those on the right-hand side of that staircase are non-metals. You'll notice that the elements in red are slightly in between the two. These are the metalloids. They have properties of both metals and non-metal. We can also look at the states of matter on the periodic table. Again, most of them here in the light green colour are solid at room temperature, 25 degrees Celsius. However, there's quite a few that are gas at room temperature, here coloured in yellow. There are only 2 elements that are liquid at room temperature, bromine and mercury. That about wraps it up for the periodic table and its organisation. It's pretty cool, as you can see. Let's just have a look at one challenge to see if you've been paying attention. Here's a clock that looks a little bit different. Can you think of a reason why the elements hydrogen to magnesium are appropriate to use on this clock? If you can, just check your answer with your teacher. That's it for periodic table organisation.